Here are some examples here. I also have some stuff on the right here. This is just information that may be able to help you if you're pausing the video and you need to read something, that these things may help you. So let's just try the first question and see what we can do here. We have 23.07 plus 103 point, we'll write this down just so we can see it, 3.659 plus 9.9. Now, doing this question without a calculator requires us to use vertical algorithm, which you should all know relatively well because we've been covering this. You've been covering that since primary school. But the only thing here is that when you're doing addition and subtracting with decimals, is that you want to be lining up the decimal points when you're writing out the problem. So what I mean by that is, let's do that. I'm going to write 23.07. Now, I'm also going to write 103.659 underneath it, but see that I need to have the decimal points lined up together. I'm going to draw this so you can see that I'm lining these up. Here, I have 103 points. Oh, there's a shape problem. 103.659 and then 9.9. And so we have that. We have plus sign here, and then we have, just like we usually have for vertical algorithm, we have a straight line going like this. Now, the only thing I want you to know here, if you're a little bit, this may help you a little bit to be able to visualize, you'll see these empty spaces over here. These empty spaces represent zeros. So what we'll do here is we'll actually write the zeros in, just so we're aware of what's happening here, so you don't get confused what to do in those spaces. And just like normal vertical algorithm, you start from the right. 0 plus 9 plus 0 is 9. So, okay. 7 plus 5 plus 0 is 12. Put the 1 at the top. 6 plus 9 plus 0 is 15, plus the 1 is 16. And then the decimal point has to come down. Remember, the decimal point has to line up with addition and subtraction. 16 means there's a 1 on top of here. 1 plus 3 is 7, plus 9 is 16. So this is a 6 here. Put the 1 at the top. 1 plus 2 plus 0 is 3. And the 1 just comes down. And there is your answer. Okay, so the main thing that you need to remember with addition and subtraction of decimal points is that you use vertical algorithm and you line up the decimal points. Okay, we'll see that happen in subtraction as well with the second question. If you take a look at the second question here, I'm going to write straight into the vertical algorithm. We have 9.7. I'm going to line up my decimal points, and so the next number is 2.86. And I said, if you remembered correctly, or remembered what I said, if there's empty spaces at the back, you're just going to put a 0 there for yourself so that you're aware of what to do from here. Here we have 0. Remember, we're starting from the right. 0 minus 6, which I can't do, so I'm going to borrow from here from my neighbor. Here's 6. I'm borrowing 1 from my neighbor. I'm putting the 1 on top of here. 10 minus 6 is 4. 6 minus 8 I cannot do, so I need to borrow from my neighbor. So this was 8. This becomes 16. 16 minus 8 is 8. Remember, the decimal points have to line up. I'm just going to draw this so that you can see that they're lining up correctly. And now I have 8 minus 2, which is 6. Okay, so you can see pretty straightforward addition and subtraction, line up decimal points, vertical algorithm, add the zeros at the end if there's any empty spaces, and then conduct the operations. This is pretty straightforward moving on from here. Okay, pause the video if you need to so that you can write anything down or try anything so that you can see how you understand how to do it. Let's look at multiplication and dividing by powers of 10. Now, some of you may not know what that means. It basically means we're just multiplying and dividing by numbers, starting with 1 and ending with zeros. So 10, 10 squared, 10 cubed, that's why it's powers of 10. If you arrive at this situation, there is a special way for you to be able to do this. I'm going to show you here, and if you need to write this down, of course, you can pause this so you can do that. When multiplying and dividing by powers of 10, you'll want to move, all you have to do is move the decimal point according to the number of zeros and also according to the operation. If you're multiplying, then you're moving the decimal point right. If you're dividing, then you're moving the decimal point left. Let's take an example and see what that actually means. We have 9.7. So let's try this one. 9.753 divided by 100. I see that there's we can see here that there's two zeros. We can see here that it's a divide question. So my decimal point is going to move left twice because there's two zeros here. So it means that I'm going to move this twice. So this is equal to, I'm going to move this so you can see here. I'm going to just show you what this means. I'm going to move this decimal point twice. If I'm moving the decimal point and there's no number to hit, that number just becomes a zero. So here I have 0 point, this zero here. So there's a zero here that I skipped. 0.9753. Okay, you gotta be careful. I might draw it again here in a different color so you can see what I'm doing here. 9.753. This decimal point moves twice. So 1, 2, and so this becomes 0.09753. That's how that answer. So if you look at this answer, that's it. How I got that answer over there. Okay, I'm moving it twice because there's two zeros. I'm moving it left because it's divide. Okay, the number's getting smaller, then naturally it has to be moving left. Let's try multiplication here. I have 27.58 times 10,000. Okay, I'm counting the amount of zeros. There's 4 zeros here, so 4 zeros. Okay, just writing that down so that you can see that. And I also see multiplication, so this number's getting bigger, which means the decimal point has to go right. So now I'm moving this decimal point right 4 times. 1, 2, 3, 4. Anything that if it jumps over, but there's no number to jump over, that becomes a zero. So this answer actually becomes 2758, and then the two zeros that I skipped, and then this is your answer. Okay, very straightforward. Number one, count the zeros. Number two, take a look at the sign to determine if the number is getting bigger or smaller, and then move the decimal point corresponding to that sign. Okay, let's see how that goes. Feel free to pause the video, of course, to write any of this down, and then see if you can do it in the problems that you need to do. Let's take a look at multiplying decimals, this time not by a power of 10, which means that there is another step that you need to take here. There's no moving of decimal points. We're going to do vertical algorithm like we've been doing in the past with numbers. So if I was looking at, say, let's just do an example. So let's just do an example just so you can see. If I was doing 23 times 3, then I could easily go 23 times 3 vertical algorithm. So this becomes 9, this becomes 6. Okay, this is like an example of vertical algorithm. We're doing the same thing here with decimals, but there's a special trick that we need to do regarding this. So let's take a look at the question. 2.57 times 3. When multiplying decimals, your goal is to try and do the vertical algorithm without the decimal point and understanding how to put the decimal point back. So first you have to take the decimal point away and understand what's being affected. Then after you've done the vertical algorithm, putting the decimal point back the way that it should be. So here, I'll show you what that looks like. I'm counting the numbers after the decimal point. So here's the decimal point, okay? And I see that there's two numbers after the decimal point on the left number. On the right number, there is no decimal, so I'm fine. So here, I'm going to remember that there's two numbers after the decimal point out of the two numbers being multiplied. Then I'm going to actually just do, this is where you have to be aware of what's happening. I'm just going to do 257 multiplied by 3. I've taken the decimal point out. I don't need it. It's annoying. It doesn't actually help us. I'm going to put the decimal point back after I do the multiplication. 3 times 7 is 21. 3 times 5 is 15 plus 2 is 17. The 1 on top. 2 times 3 is 6 plus the 1 is 7. So 771. Then, and this is very important, I'm not going to put the decimal point back yet. What I'm going to do is I'm going to write, I should probably put the 2 away from here. I'm going to write equals up here. I'm going to write the answer here because this is the actual answer to the problem. I'm going to write 771 because that's what I got with the vertical algorithm over here, right? But now, how many decimal points were there? Well, we remember there was 2. So I put the decimal point back. I go 1, 2. So the decimal point goes back here. Okay, I don't need these lines, but that allows you to see that I can conduct a multiplication without the decimal points. If I count how many numbers after a decimal point there are, remove it, and then put it back where it came from. Okay, let's try see what happens when we do that for question B, where there's numbers decimal points on both numbers. Here we got 4.13 times 9.6. Okay, now taking a look at this, we can first count how many numbers there are after the decimal point. There's 2 on the left number, 1 on the right number. Add them together, we have 3. There's 3 numbers after the decimal point. I'm going to conduct my multiplication now without the decimal point at all, okay? Because I already know what's happening here. I might have to move this down. Okay, let's try this. So we have 3 times 6 is 18. 1 times 6, 6 plus 1 is 7. 6 times 4 is 24. So I'm writing this. Now, magic 0, double on the 9. 3 times 9 is 27. Put the 2 at 0. I don't need this anymore. Put the 2 at the top. 1 times 9 is 9, plus the 2 is 11. Put the 1 at the top. 4 times 9 is 36, plus the 1 is 37. Then I add these together. So this is 8, 14. 1 plus 4 is 5, plus 1 is 6, 2 plus 7 is 9, 3 is here, okay? Sorry, the reason I'm doing this very quickly is because you should all be pretty fluent with vertical algorithm multiplication. The main part is seeing how the answer then gets written. We're going to write the same number, 39648, but this time we're going to move the decimal points back 3 times because we counted it 3 times. 1, 2, 3. So the decimal point goes right here. Okay, that is your answer. Okay, feel free to pause this video here to make sure that you're writing everything down. Okay, let's take a look. We're going to do the final one now with division. We don't have a lot of time. We're going to show you what's happening here. I'm just going to show you what we need to do here. With question A, we can just do division the normal way. That if we're looking at the divisor is 4, it's on a decimal number, so we can just do this division with short division or long division, depending on what you like to use. And we can write down this, okay? Now, the decimal points have to line up. The decimal points have to line up, which means that this decimal point has to line up here, which means this is where the decimal goes. 4 goes into 3 no times. 4 goes into 35. 8 times. Okay, so the remainder is 3. 4 goes into 37 9 times, remainder of 1. 4 goes into 15 3 times, remainder of 3. 4 goes into 36 9 times. And then we have the answer. Now, without the decimal point, it would have been 8,939, but with the decimal point, it is 8.939. So that just works. This is really nice. Okay, we're just going to quickly do the question B. Remember, question A, what happened here was that what was really nice about question A was that the divisor was a whole number. Here in question B, our divisor now is no longer a whole number, which is very problematic. We need to fix this problem by making it a whole number. We can do this with a special trick, actually. If you move the decimal point on the left-hand side, on the left number, you can also do it on the right number, and it actually keeps division the same. So our goal here, if you can see it already, is to move this decimal point until the right number or the divisor becomes a whole number. If I do this, we actually create 6,413.7 divided by 3. Okay, we've just created this because now 0.03 after moving the decimal point twice over becomes 3, and we can start the problem straight away, just like the problem that we had before. Okay, remember the divisor has to line up. I'm going to put that here, and we just do the problems. 3 goes into 6 twice, 3 goes into 4 once with a remainder of 1, 3 goes into 11 3 times with a remainder of 2, 3 goes into 23, 7 times with a remainder of 2, and then 3 goes into 27 9 times. And we've just done this problem very straightforward, just like the way we did it before, except this time, if the divisor is not a whole number, you move the decimal points on both numbers at the same rate in order for you to be able to get the problem that you need. Okay, so hopefully this helps. Give it a go and see how you go.